Welcome back, guys. This is question 5.51, and the statement of this question is three people toss a fair coin and the odd one pays for coffee. If the coins all turn up the same, they are tossed again. Find the probability that fewer than 4 tosses are needed. Okay, so this is the statement. Now first of all, let me write the given data. Okay, so what are the conditions which are given here? So there are three people who are tossing a fair coin. If the coins all turn up the same, they are tossed again. Okay, what does it mean? The three people are tossing a coin and the odd one of them, okay, if one is tail, two are heads, then this tail will pay for the coffee. Similarly, if one is head and the other two are tail, this heads one will pay for the coffee. Okay, so this is what we have. Similarly, there can also be the option that all the three outcomes can be the similar one. I mean, it can be tail, 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 or it can be heads, heads. Okay, so in mathematics you know that how to write this or can be written as plus. Okay, and to write the probability that all are same, we have to write the probability of tail multiplied by the probability of tail multiplied by the probability of tail plus probability of heads, the probability of heads multiplied by the probability of heads. Okay, what does it mean? This is basically the probability that we are getting the similar outcomes. Okay, so here putting the values 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2 plus 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2, because these are independent of each other, or it can be 1 by 8 plus 1 by 8. So ultimately it will give me 1 by 4, which is the probability of similar outcomes. Okay, that is what we have. Similarly, the probability of the different outcomes in which one is the different, this can be found out by 1 minus probability of similar. Okay, so it will be 1 minus 1 by 4, which is 3 by 4. Okay, so that is what, that is basically the probability that we will get the different number of items here. Okay, which can be either this or this, in which the odd number of the item will be present here. Okay, so now in order to find the probability that fewer than 4 tosses are needed, one we can write, let me write here the solution. Here the probability that x is less than 4, it can be what? It can be written as either in the first toss we will get these total number of items, which are what? Which are basically the different one. Okay, so this can be the first trial in which we can get this 3 by 4 probability, or it can be the second one, means in the first trial we will get this similar, and the second one we will get 3 by 4. So this would be 1 by 4 multiplied by 3 by 4, or okay, so this was the first trial, this is the second trial. In the third trial we can also get what? There is also a possibility that in the first two trials we will get the similar ones, which are 1 by 4 multiplied by 1 by 4, and the last one we will get 3 by 4. Okay, this is also a probability. So these situations can also occur here. Now writing them here, it will be 3 by 4 plus 3 by 16 plus 3 by 64. Okay, so now this is what we have. Adding them all together, what we will get, the answer of it would be 63 by 64, and that is what? That is basically the solution of my question 5.51. 5 1. Okay, so that is basically the solution of my question, in which I have basically used what I have used the geometric probability theorem. This is for the condition where we will get the success in the first trial. This is what we will get the success in the second trial, while this is what we will get success in the third trial. Okay, so that's what we have done for today. If you have any question, you can ask me in the comment box. See you soon.